Welcome to Math TV with Professor V. In this video, we're going to learn about the quadratic formula. This is part of the Intermediate Algebra video lecture series. And if you'll recall, in the previous lesson, we went over how to solve quadratic equations using the square root method as well as by completing the square. And now we're going to learn another method, which is using the quadratic formula. So the quadratic formula actually didn't just pop out of thin air. It comes from completing the square on a generic quadratic equation that's written in standard form. So remember, quadratic equations occur when the highest power or exponent on the variable is a 2. And in standard form, we have them written with all the terms on the left in descending powers set equal to 0, like this: ax squared plus bx plus c equals 0. So say I wanted to go ahead and solve for x in this equation by completing the square, like we did in the last lesson. So what would you do? Well, first things first, I'd move that constant c to the other side. So here we would have I don't like that ax squared plus bx equals negative c. And then remember, we only complete the square when the coefficient on x squared is a 1. So if it's not a 1, we divide through by whatever it is. So I'm going to do that right now. And for the sake of this discussion right now, we're just going to assume that a is positive, okay? That a is greater than 0. So now I have x squared plus b over ax plus, I'm going to try to figure out what I need to add to complete the square, equals negative c over a. And remember, I'm going to add the same thing over there as well. All right, well, when we're completing the square, remember, you take the coefficient of the linear term, divide it by 2, and then square it. So whenever you have a fraction, it's easier to think of it as multiplying by 1/2 when you divide by 2, and then we're squaring this quantity. So this would be b over 2a squared. And you distribute that exponent. So that's the same as b squared over 4a squared. So that's what's going to go in the blank. That's what's going to make a perfect square trinomial on the left. And I got to add the same thing, be nice and fair to the right-hand side. Okay. Good. And then remember, after we figure out what we need to add to make a perfect square trinomial, we can factor this left-hand side into, it'll be x plus b over 2a squared. Lovely. Now let's focus on the right-hand side. Let's get a common denominator for these two terms. So a and 4a squared, the common denominator is going to be 4a squared. So let me multiply this first term by 4a. And notice now in the numerator, I have negative c times 4a. I'm going to write it in alphabetical order. So I'll put negative 4ac plus b squared. And now that's over 4a squared. Perfect. Okay, I mean, it's not looking beautiful. I think it does, but maybe to you, not so much. It's okay though. This is going somewhere. Stick with it. So the next step, we're ready to take the square root of both sides of the equation, use the square root method, and then don't forget we need to put a plus or minus on that right-hand side. So now we've got x plus b over 2a equals, you guys okay? I'm going to split up this radical sign. So I'm going to write plus or minus square root negative 4ac plus b squared over square root 4a squared. All right. Last step to getting x all by itself is to subtract b over 2a. So x equals negative b over 2a. And then I have plus or minus square root. Instead of negative 4ac plus b squared, wouldn't it look better if I wrote b squared minus 4ac? Oh, good. I'm glad you agree. And then square root of 4a squared. We know technically that's the absolute value of 2a. We've talked about this before. So square root of 4a squared is the absolute value of 2a. But because we assumed that a was positive, then I can drop the absolute value and just write 2a. What if a was negative? You would just repeat this process and then just add an extra minus sign, and that would just switch this around, but everything would essentially turn out the same, okay? So I'm gonna have just 2a down here. And then now, notice we've got a common denominator without even trying, 2a, 2a. So let's just put everybody over the same denominator that's on the right-hand side. So negative b plus or minus square root b squared minus 4ac all over 2a. And lo and behold, there's the quadratic formula. I get excited every time it happens. So the quadratic formula comes from the process of completing the square. So essentially, both solution techniques are equivalent. They can be applied to any quadratic equation. However, the quadratic formula basically just cuts to the chase. You don't have to go through the process of completing the square. The variable is already isolated for you. All right, so just to summarize here, remember when using the quadratic formula, you need to have the equation in standard form. So all the variables on the left set equal to 0. A can't be 0 because then otherwise you wouldn't even have an x squared or quadratic term. And I tell my students, make sure a is positive. I don't even try to use the quadratic formula unless I multiply through and make sure a is positive because it gets just too messy. A lot of students mess up keeping track of that negative. So I'm just going to rewrite it one more time. X equals, I say opposite of b just because if b is negative, it'll make it positive, plus or minus square root b squared minus 4ac. And then here's another pet peeve of mine. Make sure everything is over 2a. Don't cut that fraction bar short and exclude that first term, okay? So that's it. Let's work on a few exercises. We're going to solve in the real and complex number system, so buckle up. First one, x squared minus 5x plus 4 equals 0. Okay, obviously we could solve this by factoring, right? And typically, if you were allowed to choose any method, choose factoring. Choose the easiest, slickest one. However, I just want us to practice the quadratic formula, so we're going to do it that way in this lesson. Generally speaking, though, I wouldn't do this, nor would I recommend it. Okay. So a is 1. The coefficient of x squared is 1. The coefficient of x, that's b, that's negative 5. And the constant c is 4. So here we go. X equals the opposite of b. That's going to be positive 5. Plus or minus square root b squared. So that's negative 5 squared. Are you putting your parentheses in the right place? Around the negative 5, but the 2 doesn't go in the parentheses? Be careful. Minus 4 times 1 times 4, 4ac, all over 2a, 2 times 1. All right, so this is 5 plus or minus square root. Negative 5 squared is 25, minus 4 times 4 is 16. This is all over 2. So we have 5 plus or minus square root. 25 minus 16, oh, that's 9 over 2. So we have now 5 plus or minus 3 over 2. So let's see, we've got 5 plus 3 over 2. That's 8 over 2, so 4. And then we also have 5 minus 3 over 2. That's 2 over 2, so 1. So we have two solutions, 4 or 1. The order that you write them in the solution set doesn't matter because it's not an ordered pair. They're just two x values. Okay. So yes, like I said, this quadratic equation factors into x minus 4, x minus 1 equals 0, and bam, you could already tell the solutions would be 4 and 1. This was just to practice. Don't use the quadratic formula on everything. If you can factor, factor always. Okay, next one, x squared plus 3x equals negative 7. Before we start setting up the quadratic formula, we have to put this in standard form. So I'm going to move the negative 7 over, so this is x squared plus 3x plus 7 equals 0, right? Which means A is equal to 1, B is 3, and C is what? Very good, positive 7. Okay, so we have x equals, make sure you always write whatever the variable is equals. Don't just plop down the right side of the quadratic formula with nothing equal to it. Opposite of b plus or minus square root b squared minus 4ac. And then this is all over 2a. Okay, so we've got negative 3 plus or minus square root 3 squared, that's 9, minus 4 times 1 times 7, 28 over 2. Ooh, hold on. 9 minus 28, that's going to be negative 19. So this is negative 3 plus or minus square root of negative 19 over 2. Now, depending on what class you're in, if your teacher just says find the real solutions, then you would be done right here. You would say there's no real solutions because when you take the square root of a negative number, you get a complex solution. If you've been following along with these lecture videos, we've talked about how to solve complex solutions and how to work with complex numbers. So you would just keep on trucking. You would say, oh, okay, this is negative 3 plus or minus I rad 19 over 2. And that's it. Typically, when we write out our solutions for complex numbers, we separate the real and imaginary part. So sometimes you'll be required to write it as negative 3 halves plus or minus rad 19 over 2i. That's standard form for a complex number, but it really just depends on your textbook and on your teacher, okay? So either one is fine. If I've been doing the quadratic formula though, I usually just leave it all together. Negative 3 plus or minus I rad 19, like that, over 2. But just check with your teacher, check with the book, do what the instructions say. A lot of success in math just hinges on following directions. Okay, example C. M squared equals 2/3 m plus 4/9. I'm going to tell you right now, you can do the quadratic formula with fractions, but don't make life difficult on yourself. So I'm going to multiply everything through by 9 first. So this is now 9m squared equals, it has to distribute to everybody, yes? Okay, so 2/3 m times 9, the 3 cancels, so that's going to be 6m plus 4. And then again, we need to set this equal to 0, so we've got 9m squared minus 6m plus, or minus 4, excuse me, equals 0. Okay, if you need to list out A, B, and C, go ahead. Let's do that up top. So A is 9, B is negative 6, and C is negative 4. All right, why don't you guys go ahead, pause the video, give this one a try, and see if you can get the answer. Okay, first things first, I want to make sure, did everybody write M equals? You didn't just plop the quadratic formula on there? Okay, good. Opposite of b plus or minus square root, I'm going to skip a couple steps. B squared is going to be 36 minus 4 times 9 times negative 4 all over 2a, so all over 18. So this is 6 plus or minus square root 36 plus, why plus? Because these two negatives cancel out and give me addition. 4 times 9 times 4 is 144 over 18. Okay, then from here we've got 6 plus or minus square root 36 plus 144, that's 180, and this is all over 18. So let's see, what's the largest perfect square that divides into 180? It's 36. 36 times 5 is 180. So this is 6 plus or minus 6 rad 5 over 18. And then we can cancel out a 6 from everything in the numerator, and the denominator becomes a 3. So our final answer is 1 plus or minus rad 5 over 3. We might as well just put that in the solution set so we don't have to draw or rewrite that answer again. Okay? Very good. How was that one? So my tip to you, if there's fractions or decimals, clear them out, okay? You're not a hero just because you trudged through the quadratic formula, making it unnecessarily difficult for yourself. Okay, example D, 5x times x minus 1 minus 7 equals 4x times x minus 2. So we got some cleanup to do before we can bust out the quadratic formula. So let's distribute on the left. This is going to be 5x squared minus 5x minus 7 equals 4x squared minus 8x. Okay, so setting everything to 0, I'm going to subtract 4x squared. So now I just have 1x squared. If I add 8x, now I have plus 3x minus 7 is 0. So let's see. A is 1, B is 3, and C is negative 7. So x equals opposite of B plus or minus square root b squared minus 4 times 1 times negative 7. We good? You just got to keep practicing these, and then you're going to memorize the formula lickety split over 2a. Okay, so what is this? This is negative 3 plus or minus the square root of 9. And then again, look, because we have a negative here multiplied by another negative, this becomes plus 28 over 2. Over 2. So let me just go ahead, put it in the solution set because it's not going to simplify further. That's negative 3 plus or minus the square root of 37 over 2. All right. And, you know, should you choose to complete the square, which you shouldn't, you would get the same answer. I only complete the square when the directions indicate I have to do so. Because remember, completing the square and the quadratic formula are essentially equivalent methods that can be used on every quadratic equation. It's just one cuts to the chase. So unless your teacher or the directions explicitly state complete the square, don't ever do it voluntarily. It's more work, and I don't think they're paying you. Okay? Good. Now, we can sometimes use the quadratic formula to solve equations involving quadratic functions, as well as to solve equations that do not, at first glance, appear to be quadratic. So here's an example where you need the quadratic formula, but the directions didn't explicitly state that. Let f of x equal 4x squared minus 2x minus 3. Find the x-intercepts of the function. So let's remember x-intercepts, those are the points where the graph hits or crosses the x-axis. And when the graph crosses the x-axis, that means the y value there is equal to 0. So I'm going to set y equal to 0 to find my x-intercepts. And in this case, remember f of x and y are essentially the same thing. More info in f of x, but basically I'm going to replace f of x with 0 now. So in order to find the x-intercepts, now I do actually have to solve this quadratic equation, 4x squared minus 2x minus 3 equals 0. And again, if it factored, I would say factor, but this one doesn't. So it's time to use the quadratic formula. So let's see here, we've got x equals, opposite of b is going to be positive 2 plus or minus the square root of b squared, so negative 2 in parentheses squared, minus 4 times negative 3, all over 2 times 4. Oh, so beautiful. Okay, so this is 2 plus or minus square root. Let's see here. Negative 2 squared is positive 4. And then again, look, this is going to turn into positive 4 times 3. That's going to be 48 all over 8. So what do we have here? This is 2 plus or minus The square root of 4 plus 48 is 52 over 8. 52 is 4 times 13. So that's going to be 2 plus or minus 2 rad 13 over 8. And this we can reduce everything by 2 again. So don't forget that 2 will become a 1. It doesn't just disappear off the face of the planet. And then in the denominator now we have a 4. So this is 1 plus or minus rad 13 over 4. Okay, I didn't answer the question though. It asked for the x-intercepts. So those are points or ordered pairs, right, where the graph hits the x-axis. So don't just say what x equals. You have to give your answer as ordered pairs, as coordinates. So one of the x-intercepts is 1 plus rad 13 over 4, comma 0. And the other is 1 minus rad 13 all over 4, comma 0. Now I've answered the question, okay? So make sure you take the time to write that step and give your final answer as ordered pairs. Now, in this situation and in others, it may be useful to find a calculator approximation to a solution, especially if you're going to be asked to graph the parabola using the x-intercepts and a couple other points. You know, I don't look at 1 plus rad 13 over 4 and right off the bat know where to plot that on the x-axis. So I want you guys to practice, make sure you can do this in the calculator, 1 plus rad 13, and then divide all of that by 4. If you round to 2 decimal places, you should have about 1.15 as your x coordinate, comma 0. Again, always check with your instructor as far as how much they want you to round, because that's important. I'm just checking that things didn't change since like a year ago when I did this problem. Yeah, it's still 1.15. Don't we love it? Okay, and then 1 minus rad 13 over 4 is going to be negative 0.65, comma 0. Now, these are the exact solutions because we didn't round them. We didn't tamper with them. We left them with radicals. These are approximations, calculator approximations. Default in math is you give an exact solution unless instructed otherwise. So don't get too happy-pappy with that calculator and just bust it out anytime you feel like it. You know, try to stay calculator free unless it's absolutely necessary. That's my little spiel for society nowadays. Try not to be so dependent on that calculator. Anyways, it's just good for the brain. That's really what it boils down to. So that concludes the lesson. Hope you enjoyed it. I do love the quadratic formula because it's so useful. And even when I was teaching Calc 3, some of them forgot it. And they were like, oh my goodness, we learned that forever ago. Well, doesn't mean it's any less valuable now, okay? So make sure when you're memorizing it, you put it in a safe space in your brain where it's not going to slip out. And I do have a funny little story. My uncle, I've talked about him before, my bodybuilder uncle who taught me how to lift weights that I love dearly. He remembers the quadratic formula. And no, he never needed it in life, but obviously it left such an impression on him when he was growing up, his math teacher or something, that he can still recall it to this day. Yes. So stay tuned, give this video a thumbs up, subscribe if you haven't already, and I'll see you guys for the next lesson on studying solutions of quadratic equations soon.